Good evening, everyone. Welcome to Criterion D question. Yeah, okay. Okay, now let us continue. So, towards the end of the 20th century, China was faced with a significant increase in the demand for electricity. Okay, electrical energy consumption between 1975 and 2005, China compared to the world average. The graph is being shown over here. See, on the x-axis, you can see the years, which is from 1970, 75, 80, and so on. So every grid over here shows, one big grid over here shows 5 years, which means every small grid over here shows one year, right? One year over here. Okay. And then on the y-axis, you see it is given as electrical energy consumption per kilowatt hour per per person per year, not in per kilowatt. Right? It's a consumption per person per kilowatt hour per year. So that is what is being given over here. So this kilowatt hour should not come here. It should be the unit that is being mentioned over here. This kilowatt hour. Okay. So what it gives you? It gives you the electrical power consumed by every person per year in terms of kilowatt hour. That's what is being given. And there are two graphs shown over here, which are line plots, which tells you one of the plot is a blue color line, which tells you how much consumption China has done over the years and how much consumption the entire world average has been done. Okay. So as you see, initially the China's consumption is seen to be much lesser. Okay. And then when we go for something like around 1997, 1998, somewhere over here, you see the consumption is almost the same. And after that it increases, and then you see in the year 2005, China has consumed a lot amount of electrical power as compared to the average resources consumed by the entire world. Okay. So this is what is the question. See, whenever an infographic is given, infographic means a graph or maybe an image or whatever is given, the first thing that you need to do is you need to first understand what is that graph given. Okay. So have a template built in your mind saying that, okay, this is what is being given, and then we need to ask the questions or we need to read the questions. Okay. So we have understood what does this graph gives you: power versus time, power versus air. Okay. And then there are two graphs which are being given over here. Okay. Now the graph above shows the electrical energy consumption in kilowatt hour per person in China compared to the world average. Okay. So by looking at the graph, we have understood this part. Right. Now let me move on to the next question. So first question says it's for 2 marks. Use the graph above to outline how China's electrical energy consumption per person changed over the 30-year period shown by the comparison with the world average. So what is being asked is asking you how does it change? How does the consumption, China's electrical energy consumption change? So what do we need to write? 30-year average. This 30-year average, see, it starts from 1970 to 2010. Anyway, but here it is going from 1975 to 2005 over here. So what is this 1975 to 2005? So just a minute. Okay. So is it 30 years over here? 75 to 2025 plus 5, 30 years. So he is asking only about this particular information, only from here to here. From here to here. Okay. Now let us understand what is given. So use the graph about to outline how it has been changed. So initially, now you need to just mention about what does that graph actually gives you, and write it down so that you at least write at least something like 2 points over. Okay. So what are the 2 points that you are going to mention? Now let me go back. The first point is you see the China's growth, the China's power consumption initially was seen to be how much, which was seen to be around 750 or 700 in 1975. By the world average was seen to be much higher. Okay, this was around 1400 was seen here. Then after that, what happens? In a span of 1975 to until 2000, the span of 25 years, the China's what you call power consumption started growing. Okay, and it surpassed this one in the year 2005. So you are going to write two things over here. The first one, what you are going to write? You are going to write initial condition. The second one, you are going to write growth of this. How did the growth happen? Okay, that is what you are going to write. And towards it, what all points are you going to write over here? Okay, what all points are going to write over here? So initially you can say China's power was seen to be 750 kilowatt hour, okay, per person per year in 1975, okay, and then it was significantly lower and was significantly lower than the world average. Okay, what was the world average? Go back here. So the world average was around 1400, right? It was around 1400 kilowatt hour per person per year. See, the purpose of asking this question is that how did you read the data? Okay, what is that you understand from the data, from the graph? You cannot say this point is lower, this point is higher, and so on. You need to interpret. That's very, very important. Okay, then what happens? Growth. China's growth consumption was higher and at a faster rate. When did it evolve with faster rate? Let us look at this. See, here almost the graph is going significantly. See, this rate and this rate is almost parallel here. And after this, you see, this goes like this. See, I will draw this graph here. So this goes like this over here. While this one, okay, taking this point from 1990 somewhere here, okay, so this goes something like this over here, So what does it tell you? It tells me that the growth is increasing, growth rate is increasing from the year 1990. Okay, that is what we need to write. Okay, China's growth consumption was higher and at a faster rate, it became a faster rate, okay, from 1990. So now we have mentioned, okay, how does the what you call the slope changes, and it has surpassed, okay, and it has surpassed by the year, or maybe you can say, should you go with surpass, you can say that yeah, you can say that it has surpassed the world average. When did it surpass the world average? When did it cross the world average? That's what I meant to say. Okay, somewhere around 2000 it was a bit higher. Okay, somewhere you can say around 2000, 2002 somewhere. Okay, world average during 2000, okay, and you can say while the world average was still lower, this was, go back here. See, whenever you write any comments over here, there should be some statistics included. Without statistics, okay, so this is of no use. Okay, so therefore you can say see, in 2002, where was in 2000, what was it? This is in 2000, right? Oh my god, this is in 2000 here. So this is in 2000. This is okay. So here it is 2000. 2000. Oh, I'm sorry, I'm not looking here. So this is 2000 here. So x-axis I need to look. So this is what the kind of mistakes we make. Okay, so this was somewhere in what was the date here? 1998. 1998. 2002. 1999. And during 1998, it surpassed the world average during 1998, or maybe because at 1998 it was exactly the same value. So you can say it was it surpassed more than 1990, or maybe you can put this as 2000. This would be the better answer for it. Okay, and then what you would say is that you can say, and in 2005, okay, since you described the initial point, you have to describe the final point also. And in 2005, the consumption by China has increased beyond the world average. Beyond the world average. Here also, it's better that you write down the values also. Consumption by China in 2005. What was the value here? This was seen to be in China. It was seen to be 3,100. I think 3,100, and here it is seen to be around 2,700. Okay, 3,100, 3,100 versus 2,000. Write it properly. Okay, do not mention versus over here. I just wrote a shortcut, but you have to write it appropriately. Okay, suggest a possible reason for the trend you described in part A. See, why did I get this idea? Because when you read this question, so this is what is expected over here. So you have really described the entire trend over here. This trend is very much described, so it is very much required. So you can continue. The possible trend as you described in part A. Okay, so what is the possible trend? Why should this increase? What is the reason behind this? What is the reason for the trend? You can say first is industrialization, or maybe you can say growth of factories, right? Then this is only for 1 mark, but anyway you can also put across many things. Okay, urbanization could be one of the reasons, and you can say better cost of living. Okay, one of these reasons is sufficient for you, but if you write all the three, nothing wrong. Okay, maybe you can see, because at that time you may not know, okay, what is it to write. I'm just giving you 3 examples, and you can mention whatever you want. Okay, so therefore these could be, one of these examples can be put across. Okay, then the graph shows the population of China during the same period of time as the graph in part A. Okay, part A, okay, the one which we had there, right? The total number of units of electrical energy consumed in China in 1975 was seen to be 6.24 into 10 power 11 kilowatt hour. Okay, so using appropriate data from the graphs, calculate the total energy consumed in China in 2005. Okay, you have to use both the graphs to understand what is the total electrical energy consumed in China. Okay, now how do you do this? Show your working, give your answer in kilowatt hour. Okay, so how much marks is this question? Let us see that. I think this should be for 3 marks. Okay, now we need to calculate this. Now how do you do it? What is he asking for? He is asking for calculate the total electrical energy consumed in China in 2005. Now in 2005, what was the population? Population in 2005, see, at this point, if you draw a line here, it is this value. This value is equal to how much? 1.25 is 1.3 here, and this should be 1.26 or 1.27, I think. 1.27. Okay, let us take. So what is this now? 1.27 billions. 1.27 billions is the population. Now in 2005, let me go back here. In 2005, what is the China's consumption here? China's consumption is seen to be, this is 3,000, this is 3,000, second chart over here, 3,200. 3,200 kilowatt hour per person per year. Let me write down that also. So from the second graph, I get 3.2. What is this? 3,200, not 3,200. 3,200 kilowatt hour per person per year. Okay. Now, based on these two, now I need to calculate this. What do you need? You need energy. Okay, the total energy. Now, how do you write this? So, what you do is, you can now say 1.27, right? 1.27. Okay, so energy should now be equal to. We can now write this as energy per person multiplied by total population. Multiplied by total population. Total population is given here, and the energy per person is known to you. Just substitute this value, 3,200 kilowatt hour multiplied by this 1.27. 1.27, I will take this 1.27 billions. So what is the conversion for billion? 1 billion is equal to 10 to the power of 9 people over here. Okay, so So this is person over here, people over here. So this and this unit cancel away. So you only get kilowatt over here. You need to calculate this value, and let me do the calculation. Pick up calculator here. Right. So I get the answer as 3200 multiplied by 1.27 is equal to 4064. 4064. I get this as 4064. 1.8, 4064, and into 10 to the power of 9 kilowatt hour. Give your answer in kilowatt hour, so I can just keep it like this. Don't convert this into something like 10 power 12, 10 power 8 and so on, and give some conversion factors. Don't do all these things. Okay, so you can keep it this over here, but still, you know, here it is given like this over here. So what you do is write in scientific notation. So what you do is you write this as 4.06 into 10 to the power of 12 kilowatt hour. So why do I keep like this over here? Because, you know, so there are three significant figures over here. Okay, so here also you see three significant figures in some regions, so therefore I have taken this in three significant figures. Okay, so here also you see it is so much over here. Total number of units. Did I take 6.24 here? Total number of units consumed in 1975 was 6.24. I think that's right. Yeah. Okay, so that's I get this answer over here. Next, question 7D. To meet this rising demand for electricity, China started looking for ways in which to supply the electricity its citizens needed without the need for the fossil fuels. State without the need for the fossil fuels. Okay. State three environmental problems that are associated with using fossil fuels for the generation of electricity. So the question here is that what are the alternate methods? He is not asking you that. He has only asked you what are the problems associated. Okay, read the question properly. Okay, so many people make a mistake. Many students make a mistake. Okay, by writing what are the alternative methods. You will mention about hydroelectric power, nuclear energy, that this thing. Don't mention all this. So it's not required. So he has asked you only about environmental problems associated with using fossil fuels. The first environmental, so how much marks is this for? 3 marks over here. Okay, so you need to mention about three points over here. There's only one box. There's 3 boxes actually given. I was not able to accommodate all of them, so I have just put one over here. So the first one I can say is, maybe you can say climate change, or you can say this is global warming. Okay, but you need to mention why, what happens over here. So why does it happen? Burning fossil fuels releases lot of CO2, carbon dioxide, and what do? They trap the heat, and hence what happens? The temperature of Earth increases, thereby creating global warming. When you come to next year, when you are coming to IB1, if you are studying IB1, or maybe in your 11th or your 12th standard, whichever course you take, you will be learning about this into detail, and you will be learning that when the pollution was not there, when you did not have the concept of factories and so on, the temperature of the Earth was seen to be much lower. It was seen to be around minus 17 degrees centigrade. Okay, and slowly, because of global warming, now it has gone to around 40 degrees centigrade. Okay, now let me take up the second point. First point we have written. What's the second point? When you burn the fossil fuels, burning fossil fuels, what else can create? It creates, or it releases SO2, sulfur dioxide, and NO2 also, nitrous oxide, or nitrogen oxides, and so on. So what will happen with this one here, along with the carbon dioxide? So they react with water, right? They react with water or moisture in the atmosphere to create acid rain. acid rain. So when it creates acid rain, what happens? The rains are now consist of the pH of the rainwater will be different, and as a result of it, what will happen? It will damage the forest. Damage the forest. Oh, damage the forest, and then what else can happen? It can pollute lakes and rivers, etc. This can do also. Okay. Then third one. See, since the statement here is state over here, I don't expect you to write so much, but at least some part of it you need to write. Just don't mention over there. You need to write that also. Okay. And then what else happens? Third one. Air pollution. What is the risk associated with air pollution? You can have health risk. This can give rise to something like air pollution, respiratory issues. Today's generation has lots of issues. The reason is because of these kinds of problems. Okay, so all this is something like a chain problem. One leads to the other, but that's how people are one group which works completely on this and says you have to somehow avoid all this, but unfortunately nothing can be done. It's continuing like this. So all the trees, forests, everything has been chopped off, and what you observe now is only concrete buildings. Okay, next. One alternative method for the generation of electricity is the hydroelectric power. A typical hydroelectric facility is shown over here. What is happening? You construct a dam over here, and then you have a reservoir of water. You definitely need to look for places where this can be constructed, and water is made to allowed to fall down by creating a path over here, and then as it falls down over here, it comes to the ground level, and there is a turbine which has been fixed. The turbine starts rotating, and because of this turbine's rotation, you can see electricity is being generated, and this is now connected by collected in the form of a transformer, and then the transformer uploads it, or it increases the voltage, and then it sends it to the power output, and that's what we can get it. But to get this one, it's not so easy, because only appropriate regions can be used, and the moment you are creating something like a dam, what can happen is that the flora and the fauna of the natural environment is completely lost, right? If suppose in case of a flood, what can happen is that this region can completely flood the nearby villages, towns, or whatever it is. So you have to be very careful while doing this. Okay, so there are problems associated with everything. Okay, now what is the question? The question is not about that. Drag and drop the energy forms shown below to outline the main energy transformations that takes place in a hydroelectric power plant. Okay, so what are the main energy transformations? See, here I am not able to drag and drop. See, I need to take this one, click the mouse over here, and I put it across. I am using a PowerPoint, taken a snapshot of this question paper that's already available, and then I am putting it across, so I can't do it. But instead, what I can do is I can just write some numbers over here and say what comes first, what comes later, and so on. So first one is gravitational potential energy. Okay, so when you say you are storing water to a larger level, definitely GPE comes first, and then this water is now made to fall down here. So kinetic energy comes next, right? When it falls down over here, it increases the speed of the turbine. When it increases the speed of the turbine, naturally more amount of electricity is generated. So finally, you can say electrical energy is generated. So these three are not required. So these three are what is actually happening. So with this, we come to an end to this particular problem. I hope you come to know about how to solve such problems, how to write so such answers for it appropriately. So many of you will see that you just write something like only one line answers. This will not be sufficient to score complete marks. So this is what is essential. So with this, we come to an end. Do like, share, and subscribe to my channel for more such updates. Thank you.